All right, well, let's take a look at a few more of these verifying trig identities. The first video in this kind of had maybe a little bit more simplistic view of some of these problems. As we continue moving on, and the problems get a little bit harder, you need to move into a little bit more of trying to find just a little bit more of an algebraic look at what these identities actually have in them. And so let's start with number 28. If you remember, the first thing that you want to kind of look for is that any factoring, any multiplying, any adding or subtracting of fractions, and then you want to turn things to sines and cosines. Well, that last strategy isn't going to work at all in this one because there's all sines and cosines. So we already are done with that. But I do see maybe some sort of a FOIL type problem. But what catches up kids is that when you look at this, you're like, well, that doesn't even make any sense. And so the first thing that you need to do is that if you look at this problem, what actually is here is that this sine of negative y actually converts to negative sine of positive y. And we talked about that already. That's something that you should have added to your formula sheets. It should have been something that is an addition on there. So make sure that you know that that's actually what happens. Now you look at this problem and hopefully you see maybe a FOIL type problem. And so that's what we're going to do. We're going to try to FOIL it out. It doesn't always happen that it actually is the right step, but let's try it. Try something. 1 times 1 is 1. 1 times negative sine y is negative sine y. Sine y times 1 is positive sine y. And sine y times negative sine y is negative sine squared y. Remember that the equal cosine squared y part is going to stay there. That's what we want the left side of this equation to look like. We don't want to really fool around with that right-hand side at all. Negative sine y plus sine y, those two things cancel. I get 1 minus sine squared y. 1 minus sine squared y is what I want it to be. When I look at the sheet, it's a Pythagorean identity. Cosine squared y is equal to cosine squared y. That's true. We're done. That's it. Okay, so go through. We're looking more at kind of an algebraic look at what happens with these problems. Here's number 30. And when you look at the left-hand side of this, it may look like it's going to be a pretty tough problem. And so one of the options would be that you could go to the right-hand side. Well, when you look at the right-hand side, it really ends up kind of looking like the same thing. I'm trying to go through these problems. It's been about a year since I've done a lot of them. And so I really want to kind of just run through and see and try this video with this set of problems more along the lines of how you would actually look at it as a student. You wouldn't necessarily know where to start attacking this type problem, and so I kind of want to walk through the steps that would be better for you, maybe you to go through. And so when I look at this, I don't see a lot that I can do on the left-hand side here. I've got a bunch of tangents. There's no sines and cosines in here, so that's going to be my first step, is that I'm going to say, well, tangent of x is sine of x over cosine x. Tangent of y is sine of y over cosine y. In the denominator, I have 1 minus, again, tangent x, sine x over cosine x, times sine y over cosine y. Well, again, when I look at that, that doesn't seem like it did a lot, but I do have a fraction on top here. The fraction on top, oops, sorry about that. The fraction on top, I can add that together by getting a common denominator. So I'm going to multiply this by cosine y on both top and bottom, and this one by cosine x on both top and bottom. And so on the top of this whole monster fraction, I have cosine y sine x plus sine y cosine x. all over cosine y cosine x. Okay, so that's the top of the fraction. On the bottom of this fraction, I have two things multiplied. Again, there's a subtraction, so I can make this 1 a fraction and get a common denominator, which would be cosine x cosine y. So I'm going to multiply both top and bottom by that. And so on the top of the bottom of this huge monster problem, I get cosine x cosine y minus sine x sine y. And then that's all over cosine x cosine y. Well, that's promising to me because when I look at this now, I see a fraction divided by a fraction and their denominators are the same. And so that's a pretty big thing for me because I can go and cancel these denominators out. Hold on, technical difficulties. Okay. I can, when I flip these fractions over, because I now have a fraction divided by a fraction, I end up with cosine y sine x plus sine y cosine x, the very top of this fraction, divided by cosine y cosine x. And then I'm going to flip the second fraction over, so I get cosine x cosine y divided by cosine x cosine y minus sine x sine y. And when those two things are multiplied, now those two parts are going to cancel out, and I end up with the next step of this being that I have cosine y sine x plus sine y cosine x over cosine x cosine y minus sine x sine y. This is exactly what happens and exactly what is the frustrating part about this section. I feel like I've done a lot of work, and when I look at this problem, I don't see a lot that I really makes this, as easy as I was hoping that it would be when I a second ago said that it looked promising. So what I want to do is I want to go back and I just want to erase it all. Like I didn't feel like the position that I was in was a good position for continuing to solve this problem. Okay, so we're going to erase this, and we're going to go back and try something new. So that route didn't work. Pardon the noise in the background. There's a little bit of construction going on. But let's take a look here. I'll just try to talk a little bit louder. Now, when I compare the left side here and the right side, I see that on the bottom the tangent x and the tangent y went away, and they're replaced by a cotangent and a cotangent. And so if I notice this 1 being multiplied by cotangent x, cotangent y, and if I took tangent x, tangent y, and multiplied it by cotangent x, cotangent y, I would get a 1. And so that's what I'm going to try. And hopefully it'll work out. So this is what's fun about math. You can try stuff, and sometimes it works and sometimes it doesn't. So I'm going to multiply this whole thing, this whole denominator by that, and I'm going to multiply the whole numerator by that. So in the numerator, the distributive property problem, I get cotangent x, cotangent y times tangent x plus cotangent x, cotangent y times tangent y. In the denominator, I get cotangent x, cotangent y times 1, and cotangent x, cotangent y times tangent x, tangent y. Now, I'm going to just show you why these things canceled out. If I take this cotangent x and this tangent x, cotangent is cosine x over sine x, and the tangent is sine x over cosine x. So these are all going to cancel out, and they give us 1. So those two things, when they're multiplied, actually give us 1. And the same thing here with cotangent y and tangent y, they give us 1. So in the denominator of this whole thing, I have what what my goal was, the cotangent x cotangent y minus 1. So that matches up with this. Now I'm just hoping that that the top kind of does the same. Well, we have cotangent x and tangent x. Those are going to cancel each other, so I get cotangent y. On the top I had, this was cotangent y. Cotangent y and tangent y cancel out, and I get cotangent x. And they match. So that was obviously the easier step than what we had done before, but this is exactly what you want to go through and work on. It shows exactly how these things happen, how you want to go through and you want to explore, see what happens. If it's not working out, don't beat your head against the wall and keep going. Go back and start over again. Here's number 34. So now I have a square root here. I think I'm. Oh, I thought I was missing something, but I'm not. Ultimately, from the left-hand side to the right-hand side, the square root went away. So I'm going to switch the left-hand side a little bit so that the square root does go away. So I'm going to multiply this, or square that side, which means I have to square this side. So the square root's going to go away over here. It's just going to give me, try to give me a better idea of what we were trying to hope for here. So I'm going to shoot to try to get 1 minus cosine theta squared over sine squared theta. Now, when I look here and here at the denominators, I know that if I had 1 minus cosine squared, I could turn that automatically into a sine squared. And so the way that I want to think about this is kind of like the way that we thought about complex numbers. When I see this, I want to multiply this by the conjugate, because what ends up happening is on the top I get 1 minus cosine theta times 1 minus cosine theta, which is 1 minus cosine theta squared. So the top already matches. On the bottom, when I multiply those two things, so I get 1 minus cosine theta. I don't even have to multiply it out using FOIL. I can just say that it's squared because that's what I want it to be on the right-hand side. On the bottom, I get, I do want to FOIL this so that I prove to myself and more importantly to you, 1 times 1 times cosine is cosine. Negative cosine times 1. And then negative cosine times cosine is negative cosine squared. On top, I want to leave that alone because that's already done. That's what I wanted on the right-hand side. On the bottom, the cosines are going to cancel out, and I get 1 minus cosine squared. Well, I can turn that 1 minus cosine squared on the bottom into sine squared. Okay, 1 minus cosine theta on the top squared is not 1 minus cosine squared. Okay, that actually has a middle term in there. I don't want to mess around with the middle term. Well, now this almost matches, well, what the right-hand side had. The right-hand side had this, but it had an absolute value around it. And so then the question is, well, why did it have an absolute value? How do I create an absolute value in there? And the thinking more goes along logic than doing something to it. If I had a square root from the very beginning, and I put something underneath on that denominator, and then I took a square root of it, it has to be it has to come out to be a positive. That number has to be positive. Otherwise, I couldn't have put it underneath the square root to begin with. If it were negative, then it couldn't go underneath that square root. Okay, it can't take the square root of negative numbers in the real number system. So why don't we have that problem on the top? Well, we don't have the problem on the top because when I'm taking and I'm squaring that portion of it. And so when I square that, it automatically becomes positive, and I don't have to worry about it being the absolute value. And so now the left-hand side matches the right-hand side. I went through and I changed the right-hand side, and I know that I've told you don't go through and change the right-hand side, but if you need to change the right-hand side to make those two things equal to each other, then that's fine. Okay, you can do it. It's just something that that you may want to attempt to try to avoid doing. Now, if you felt bad about that and you want to go the extra step, you could take the square root of both sides, and you could have done that above in the step above and been okay with that same answer. Okay. And then here's the last one that I kind of want to look at. Here's secant squared y minus the reason that that this problem looks a little bit scary is because of all of this, but that actually just means tangent squared of y. The variable is y, and then I want that to eventually be equal to 1. Well, if I look at my sheets, I've got secant squared minus tangent squared actually is 1, so 1 is equal to 1, and that's the end. A pretty quick one, but ultimately you needed to know work again with that stuff in brackets with that little phase shift that we had. Okay, so go through, continue working these problems. You want to keep working on them. If you get stuck, go back and try something different. Okay, go to a different problem and come back to it, but keep working, keep trying something.